Okay, good day, grade 8s. I trust that you are well. For this lesson, we will be looking at geometry of 2D shapes. Geometry, let me just close this down here so you can see what I'm writing. Geometry of 2D shapes. Now, I'm sure everyone has come across the word 2D before. It means two-dimensional. Two-dimensional is basically a flat object. It's like I'm drawing a stick figure here, right? There's no depth to it. Like you may have seen 2D animations and 3D animations, and you may have noticed that 2D animations does not have any depth to it. It has height, it has width, but it does not have any depth to it at all. So there's different two-dimensional shapes that we have in mathematics, and today we are going to focus on triangles. Now, as the name suggests, tri means three. So this is a polygon with three sides and three angles. So it's a polygon. Now I'm going to just look for my ruler so I can draw a nice straight line. So let me just look for that now. Right, okay, I am back with a ruler, right? So a triangle has three sides, right? And as you can see, it forms, so that's three sides, and it forms three angles. And we name a triangle just like how you and I have a name. We name a triangle, for example, triangle ABC. So triangle has three sides and three interior angles. We can take our protractor, that's the measurement tool that we use to measure angles, and we can measure angle A, B, and C. So if this was an investigation in class, I would have given you a triangle or made you draw any triangle of your choice, and you can measure it with the protractor. Your friend can measure it with the protractor as well, their triangle. Then you can compare what happens when I take angle A plus angle B plus angle C. So the sum of the interior angles of the triangle. Remember, this hat represents an angle. So angle A plus angle B plus angle C is actually equal to 180 degrees. And my friend may draw another triangle. Um, Maybe it's a triangle that looks something like this. Bit of a weird triangle. That looks like sort of an obtuse angle triangle. Obtuse triangle because there's one interior angle that's an obtuse angle. It lies between 90 degrees to 180 degrees. But never the case, he just draws another random triangle, and my friend can measure the interior angles of this triangle. Let's call it triangle DEF, and then take angle D plus angle E plus angle F, and that should be equal to 180 degrees. So what can we conclude about the sum of angles of triangle? We can say that the sum of angles of triangles are supplementary. It adds up to 180 degrees, and we need to know this knowledge when we are solving geometric problems involving triangles. Now, in primary school, you learned about the different types of triangle. So very quickly, I'm going to recap on that. I'm not going to spend too much time on this because in primary school, you would have looked at it as well. Firstly, we have an equilateral triangle, and as the name suggests, equi means equal. So just using my free hand, I'm going to draw a triangle here. And an equilateral triangle has all sides equal and all angles equal as well. Now keep that in mind, all angles are equal. So in an equilateral triangle, if all angles are equal, let's call this angle x. So if this angle is x, this angle will be x, and the angle on the right will also be x, right? Because all the interior angles are equal. But remember, we just concluded that the sum of angles of triangles are supplementary. It adds up to 180 degrees. So let's add the angles together. In any triangle, it's always 180 degrees. So if I take x plus x plus x, it should be equal to 180 degrees. And the reason for that is sum of angles of triangle. Now I can solve for x. So I'm going to say x plus x plus x. Those are like terms. So it's going to be 3x is equal to 180 degrees. I divide the left hand side by 3, the right hand side by 3. X is equal to 60 degrees. So what can we conclude about the interior angles of an equilateral triangle? We can say that the interior angles are equal to each other, and each angle is 60 degrees respectively. So this is 60 degrees, 60 degrees, 60 degrees. Now the next type of triangle that we have right? If I can get a new page. Right. The next type of triangle we have is the isosceles triangle. Isosceles triangle. So with the isosceles triangle, there's two sides that are equal to each other. So let's say we have triangle ABC, right? There's two sides that are equal to each other. So we can see that AB is equal to AC. And another property with regards to the angles of an isosceles triangle is that the angles that are opposite equal sides are equal. Now let me repeat that statement. The angles that are opposite equal sides are equal. Or you can think of it as the base angles of the isosceles triangle. Now, let's look at this case. We said that AB, the length of AB is equal to the length of AC. So for example, if the length of AB is 5 centimeters, then of course the length of AC will also be 5 centimeters. That is an isosceles triangle. Now, what angle is opposite to AB? And that is angle C. That's one of the equal sides. And what angle is opposite to AC? And that is angle B. So what we can conclude is that angle B is equal to angle C. So when you say an isosceles triangle, just don't assume that any two sides are equal or any two angles are equal. The angles that are opposite the equal sides are equal, and also it applies to the sides as well. So for example, if I give you a triangle like this, and I ask you, okay, class, what type of triangle is this? Let's say this is y. I do not know the value of that, but I do know that y plus x is 180 degrees, the sum of angles of triangle. So I ask you, what type of triangle is this? And of course, you tell me this is an isosceles triangle. Why? Because there's two angles that are equal to each other. But if this is triangle DEF, and I ask you what two sides are equal, do not just assume and say this is an isosceles triangle, so DE is equal to DF. That's incorrect, right? The sides that are opposite to the equal angles are equal. So for example, this is angle X and this is angle X as well. They are equal angles. Angle D is equal to angle F. So what side is opposite to angle D? That will be EF. And what side is opposite to angle F? That will be DE. So we can conclude that this is an isosceles triangle and DE is equal to EF. So that's an isosceles triangle. Again, I'm going quite fast on this because you should have looked at these types of triangles in primary school as well. So this is quite nice to recap as well. The last type of triangle that we have is the scalene triangle. And with regards to the scalene triangle, we know that with the scalene triangle, no sides are equal and no angles are equal. So for example, if this is triangle GHI, the length of, just imagine that this is a triangle. I know I do not use a ruler, but this is a triangle with my free hand. I know that GH is a different length to HI, which is a different length to GI. And of course, the angles are different, right? So I have different markings indicating the different size of the angles. Now, what's important to note, no matter what the type of triangle is or what type of triangle you have, the sum of the interior angles is always 180 degrees. So let's let's look at an example of that. Let's say I ask you to find the value of x. So I give you a triangle that looks something like that. Let's say this is 70 degrees. Let's say this is 80 degrees. And let's say this is x, right? And I ask you, okay, class, let's find the value of x. So now I know that the sum of the interior angles is 180 degrees. So I'm going to say x, that's this angle, plus 80 degrees plus 70 degrees is equal to 180 degrees. And the reason for that is sum of angles of triangle. So we have x plus, this will be 150 degrees, is equal to 180 degrees. And of course, algebra is the mother of maths. So I taught you how to solve an algebraic equation. You have to isolate x. I take 150 to the other side. Technically, what am I doing? I'm subtracting 150 degrees from both sides of the equation. So I'm going to take this to the other side. And remember, you can think of it as taking a number to the other side. So when it jumps the fence, the sign changes. So it's going to be 180 degrees minus 150 degrees x is equal to 30 degrees. So you can prove to see whether this is correct. 30 degrees plus 70 degrees is 100 degrees. 100 degrees plus 80 degrees is 180 degrees, sum of angles of triangle. Now, the last concept that we learned was the exterior angle of the triangle, right? We learned about the exterior angle of triangle. Now, let's say I have a triangle, and this time I'm going to try to be a bit fancy and use my ruler to show you this. So, let's say I have a triangle that looks something like this. Right? So let's say I have triangle ABC. So let's block this out for now. This is just triangle ABC. I'm going to take one side of the triangle and I'm going to extend it to point B. This is point D rather. So I extend side BC to point D. And what I actually did was I created an exterior angle. Exterior means outside. Interior means inside the triangle. So I created this exterior angle rather. This is the exterior angle ACD, and that's how we label an angle if you have forgotten. It's ACD. Now some people might say DCA. That's perfectly fine, but usually in maths we like to keep things neat, so we write it in alphabetical order. So whatever the size of this angle is, right, we did an investigation in class and we looked at the interior angles. Now there's 3 interior angles, but there's 2 interior opposite angles. Let me write that down. Interior opposite angles. The 2 interior opposite angles will be angle A, right, angle A and angle B. So this is an interior opposite angle, and this is also angle B is also an interior opposite angle as well. And what we did was we used our protractors and we measured the angles, and we concluded after our investigation there's something amazing that happens with the exterior angle of the triangle. We concluded that the exterior angle of the triangle is equal to the sum of the interior opposite angles. So for example, in this case, angle ACD is equal to angle A, right, plus angle B. And the reason for that is the exterior angle of triangle. And we proved that geometrically with our protractors as well. So let's look at a quick example of applying this as well. So let's say we have a triangle. I'm just going to use my freehand just to save some time. Right? I have a triangle. I extend one side of the triangle, and let's say this is 20 degrees, and this is let's say this is 30 degrees. I'll say 70 degree another degrees. And let's say this is 70 degrees, and let's call this x. Now x is regarded as the exterior angle of the triangle. So to solve for x, all I can say is that x is equal to the sum of the interior opposite angles. So x is equal to 30 degrees plus 70 degrees, and the reason for that is exterior angle of triangle. So x is equal to 100 degrees, and that is my final answer. So this sums up the content that we have looked at so far with regards to triangles. Thank you.